welcome to today's webinar, Overview and Best Practices for Amazon Elastic Block Store. Our presenter today is Neil Gadok. Neil is the Senior Product Manager for Amazon Elastic Block Store, Amazon EBS, a service which provides persistent block-level storage volumes for use with Amazon EC2 instances in the AWS cloud. He led the launch of a variety of EBS features, including increasing the maximum size and performance of EBS volumes. Neil has since helped developers and architects optimize their EBS usage to match the availability, performance, and cost needs of their workloads on AWS. Today with us, we also have Drew Meyer, Suraj Prasannan, Jody Gibney, Mark Olson, and myself, Joe Disher. We are the webinar moderators who will be engaging with you and answering your questions throughout the presentation while your presenter presents. Neil, welcome. The floor is now yours.
Great. Thank you very much, Joe, for that introduction. As Joe discussed, I'll be presenting an overview of the Elastic Block Store service and best practices on how to use the service. And again, for those watching live, there are a few poll questions. Please answer, and we'll give you some feedback at the end of the presentation. So to begin, what is Amazon EBS? First, I'll say what is not Amazon EBS. EBS is not a traditional disk drive. EBS is a service. EBS is block storage as a service. As a service, we pass on new features and enhancements out to you as you need. For example, last year we increased the maximum throughput performance of our product offerings and pass those on to you with no change in price. We're always listening to you and to determine what changes we need to make to seamlessly improve the service for you. Now again, what is Amazon EBS? EBS is block storage as a service. The service allows you to create storage volumes and attach them to EC2 instances. Once attached, you can create a file system on them, run a database on them, or use them in any other way you would use block storage. We've seen customers use EBS volumes for the boot volume of a Linux or Windows operating system, for SQL databases, for NoSQL databases like MongoDB and Cassandra, for big data workloads like MapReduce, data warehouses like Vertica, and log processing like workloads like ELK and Splunk. Amazon EBS volumes are availability zone specific, and the data on those volumes persists independently of the EC2 instance. So you can detach your volume from one instance and attach it to another instance. Thus, Amazon EBS volumes data persists independently of the instance. Now, EBS volume can only be attached to one instance at a time, but many volumes can be attached to the same instance. For example, you might want to separate out your boot volume from your data volumes. Amazon EBS volumes are automatically replicated to protect you from the failure of a single component. So what does that get you? Well, this enables EBS to have volumes that are designed for 5 nines of availability and an annual failure rate of between 0.1 and 0.2%. What does availability mean? Well, EBS is designed such that you can access your data on the volume 99.9% of the time of the year, which means only about 5 minutes per year you may be able to not able to access your volume data. What does AFR, or annual failure rate, mean? Well, it means that there's a 0.1 to 0.2% chance over a year that the data on your volume may be permanently become unavailable. So if you had 1,000 volumes that lasted the entire year, you may expect 1 to 2 to fail. So for reference, an EBS volume has an AFR which is about 20 times better than an off-the-shelf disk drive, which has an AFR of about 4%. Thus, like any critical data in your company, we want you to make sure that you're using a data protection strategy to protect the data on those volumes. This is why we have snapshots. EBS has the ability for you to create snapshots of your volumes. Snapshots are point-in-time copies of your data stored in S3. When stored in S3, the data gains the 11 nines of data durability that S3 is designed for, which is much higher than EBS volume with the AFR of 0.1% or about 3 nines. So what can you do with a snapshot? Well, once you do have a snapshot, you can use an API and create new volumes from the snapshot in another availability zone. And when you're actually creating those new volumes, you can change the size or type of the volume. You also can use snapshots to copy data to another region. Copying snapshots to another region is a common disaster recovery strategy. You also can share your snapshots. You can share your snapshots with specific AWS accounts or publicly. You can also use snapshots to create Amazon machine images, an AMI or AMI. An Amazon machine image provides the information required for you to launch your instance. Speaking of instances, now some of you may have heard about EBS optimized instances. Now what is that? Well, again, first I'll say what is not an EBS optimized instance or regular instance. A non-EBS optimized instance has a shared network pipe. Thus, EBS traffic is on the same pipe as other traffic to other EC2 instances, to other AWS services like S3, and to the internet. This is because EBS is a network-attached storage device and not directly attached to the instance. The sharing of traffic can cause increased I/O latency to your EBS volumes. So what is an EBS optimized instance? An EBS optimized instance has dedicated network bandwidth for EBS I/O, and it's not shared. So this is really important to remember. Note the size of your EBS optimized instance, for example, a 2XL or a 4XL, will define the amount of dedicated network traffic that will be sent to your volumes. C4 and newer instance families are EBS optimized by default. If you want to see more, read more details about which performance you get with which EBS optimized instances, you can see the link below. Now, also continuing on the theme of instances, some of you may have heard of EC2 Local Instance Store. EC2 Local Instance Store is a block storage that's directly attached to the instance, as opposed to network attached to EBS. Only certain EC2 instances come with local store. The difference between local store and EBS is a local store is not persistent. Your data will not persist if you stop and start your instance. Local store doesn't support EBS features like automatic replication, and thus has a different durability than the 0.1 to 0.2% AFR of EBS volumes. It doesn't support snapshots, and it also does not support native encryption. Encryption is a feature that comes with EBS volumes and can be embedded and enabled with a single clip. Now, some customers do use EC2 local instance storage. They do use it for IO-intensive applications, typically in stateless architectures. Speaking of encryption, I'll go a little bit more in detail to that. As mentioned earlier, EBS offers native encryption. Just click a checkbox and you can encrypt your boot and data volumes. No additional actions are required. You can attach both encrypted and unencrypted volumes to your instance, and encryption is supported on any current generation instance. When you're using encrypted volume, there's no performance impact. Encryption is supported with all EBS volume types, and snapshots of your encrypted volumes are also encrypted. You note there's no extra cost with using EBS encryption. So that was our brief overview. So in the next section, we're going to go over the primary EBS volume types. To start, a few definitions that you can read now or after the talk. We have definitions on IOPS, throughput, latency, capacity, and I/O size. Note, although the units are shown in GB and KB, which in reality it's gigabytes and kilobytes, all units in EBS are base 2 rather than base 10. Now to begin. EBS offers two major categories of storage. One set based on solid-state drive technology, and the other based on spinning disk, hard disk drive technology. SSDs are ideal for workloads with random and read and write operations requiring low latency and high input-output operations per second, or IOPS. HDDs are ideal for workloads with sequential I/O access and high throughput requirements at a low cost. On this next slide, we see the 4 current generation EBS volume types. I'll begin with talking about our general purpose SSD volume type, or GP2. It's the default EBS volume type, and it should be your starting point with EBS. So there's a lot of data in this slide, and I'll go through it quite slowly. So first off, general purpose SSD volumes, or GP2, are great for boot volumes, low latency applications, and bursty databases. GP2 has a simple provisioning model. You pick your volume size between 1 and 16 terabytes, and your performance will be automatically determined for you. Your performance is divided into 2 parts. At the top, your baseline performance, and then your burst performance. You get a baseline performance of 3 IOPS per gigabyte up to 10,000 IOPS, and you get a burst performance of 3,000 IOPS for volumes less than 1 terabyte in size. For larger volumes than 1 terabyte, you'll just get the baseline performance. For these numbers, we're saying I/O is measured in 16 kilobyte sizes. So that's a lot of data, so I'll next visualize this to help explain. On this slide, we're going to see on the horizontal axis the volume size, and the vertical axis the IOPS performance. First, we show the green line. The green line is the baseline performance of GP2 volumes. You get 3 IOPS per gigabyte to a max of 10,000 IOPS. Volumes larger than 3,334 gigabytes will have a baseline performance of 10,000 IOPS. Next, we're going to show the burst performance. So in orange, we see volumes less than 1 terabyte will get an extra burst performance of 3,000 IOPS. Any volume less than 1 terabyte in size can burst to 3,000 IOPS. When the burst runs out, you'll revert back to your baseline performance. For example, if you have a 300 gigabyte volume, you'll get a baseline performance of 900 IOPS and a burst performance of 3,000. Note, look in the lower left-hand corner. Volumes less than 34 gigabytes actually will have a baseline performance of 100 IOPS, not at the 3-to-1. So you can be assured that there will be sufficient performance at baseline for small volumes. On this next slide, we're going to tell you about how long does your burst last. You have a question mark. So you get burst up to 3,000 IOPS, and then the burst bucket may run out. So the duration of the burst is based on a burst bucket that comes with each GP2 volume. On creation of your GP2 volume, the burst bucket starts full with 5.4 million IOs. And with GP2, you can spend those IOs at up to 3,000 IOPS per second. So you're draining your bucket at this point when you're spending those 3,000 IOPS per second. However, the bucket is always accumulating IOPS, 3 IOPS per gigabyte per second. So the bucket is actually refilling when you're spending less than your baseline performance of 3 IOPS per gigabyte. Again, the burst bucket doesn't apply for volumes greater than 1,000 gigabytes, as your baseline performance at 1,000 gigabytes is 3,000, and your burst is also 3,000. So above 1,000 gigabytes, your baseline is greater than your burst, and you just get your baseline performance. Now again, you may be wondering again, how long does that burst last? Because it's complicated math here. So just to start off, we designed general purpose SSD based on a statistical analysis of our storage fleet. And burst durations are designed to fit most workload patterns. For an example, a volume that's 300 gigabytes in size can burst up to 3,000 IOPS for 43 minutes. And after that, the performance reverts to 900 IOPS. And again, the burst bucket will start to refill if your workload starts to use less than the baseline performance. So again, is this enough? So since GP2 is launched, we recently took a look at all GP2 volumes created by our customers over a 2-week period, and we actually found that only 0.3% of volumes had ever exhausted their burst bucket. So what we see with general purpose SSD, for almost every workload, the burst should be enough. Moving on to our next volume type. Our next volume type is Provision IOPS SSD, or IO1. IO1 is for PIOPS, is for mission critical tier 1 applications with IO intensive workloads that require the highest IOPS performance consistency. With IO1, you can provision your volume size and your IOPS independently, whereas with GP2, your performance was based on your volume size. As we can see, the top end performance of IO1 are double what we had with GP2. Instead of a maximum of 10,000 IOPS, you can provision up to 20,000 IOPS with a provisioned IOPS SSD volume. For PIOPS volumes, or IO1, are designed to deliver within 10% of the provisioned IOPS 99.9% of the time over a year. Again, IO1 are ideal for critical applications and databases requiring sustained IOPS. Again, on this next slide, we visualize the performance that you can provision with IO1. As discussed, you can provision your volume size on the horizontal axis independently of your IOPS performance on the vertical axis. However, there are some requirements for provisioning. You cannot provision 20,000 IOPS volume with a 1 gigabyte volumes. We have a 50 to 1 IOPS to gigabyte ratio setting. So at 400 gigabytes, you can provision IO1 volume at the full 20,000 IOPS. At a 1400 gigabyte size, GP2 would be at 1200 IOPS baseline and burst up to 3000. Again, on this slide, measuring all IO in sizes of 16 kilobytes. So jumping into the common use cases used for GP2 and IO1. As discussed, GP2 is great for boot volumes, low latency application, and burst databases. And PIOPS is ideal for critical applications and databases with sustained IOPS. EBS works great for SQL and NoSQL use cases. We've seen customers like CrowdStrike take these volumes and use it for Cassandra. They were able to create a petabyte scale cluster using GP2 for Cassandra. It also works well for use cases like Mongo. We've seen our friends at MLAG use it for MongoDB. If you want more information on how to use these volume types for NoSQL workloads, we have a few links on the screen. Now we move to our next volume type. Now this is a different category of volume types. This is based on HDD or spinning disk technology. First is our throughput optimized ST1 volume. Throughput optimized ST1 is ideal for large block, high throughput sequential workloads as opposed to random workloads for GP2 and IO1. So for example, you can consider using this volume for big data workloads, log processing and ETL workloads, data warehousing workloads like Vertica, and other workloads like Kafka. Like GP2, you provision the volume size and the performance is automatically provisioned for you. Like GP2, you get a baseline performance and a burst performance. However, all performance characteristics are measured in megabytes per second instead of IOPS. So with this volume type, you get a baseline performance of 40 megabytes per second per terabyte provision, up to 500 megabytes per second. And your burst performance is 250 megabytes per second per terabyte, up to 500 megabytes per second. Note, so these volumes can only be used for data volumes attached to your instance, not as boot volumes for your operating system. Also note, the minimum size of the ST1 volume is 500 gigabytes. Note, the latency for HDD volumes will include both seek time and access latency, as it's based on spinning disk technology. Thus, one should expect double-digit millisecond latencies instead of single-digit millisecond latencies that you would see with the SSD volume types. Again, on this slide, we visualize the baseline and burst performance of the ST1 volume type. In orange, we show the baseline performance, and in blue, we show the burst performance. For example, if we have an 8 terabyte volume, we have a baseline performance of 320 megabytes per second and a burst performance of 500 megabytes per second. And at 12.5 terabytes, your baseline and burst performance converge at 500 megabytes per second. Now again, how long can you burst? Like GP2, you have a burst bucket that comes with a volume. The bigger the volume, the higher baseline performance and that you'll get with this volume. So unlike GP2, the performance is measured in volume throughput, and the total bucket volume is not capped. It grows as your volume size increases. So with GP2, you get a fixed bucket of 5.4 million IOPS, but with ST1, your IO bucket increases to is 1 terabyte per terabyte in volume and size. Like GP2, you can spend your volume credits at the maximum burst rate. You can spend up to 250 megabytes per second per terabyte. And when you're not accumulating, when you're not bursting, you're always accumulating credits into your burst bucket for ST1 at 40 megabytes per second per terabyte. Our next volume type is cold HDD, or SC1. SC1 is a lot like ST1, but has a more modest performance of 12 megabytes per second per terabyte of baseline and 80 megabytes per second per terabyte for burst with a max of 250 megabytes per second. So you get about half the max performance of ST1, but it's actually half the cost. So this volume type is great for data that's accessed less frequently than ST1. So it's really good for logging applications, backups, and archives. So at 2.5 cents per gigabyte, this volume type is great value for high throughput applications requiring low costs. On this slide, we again visualize the performance of this volume. We have the baseline performance in orange and the burst performance in blue. Again, the orange line, again, we have baseline performance of 12 megabytes per second and a burst performance of 80 megabytes per second. At 16 terabytes, the baseline performance maxes out at 192 megabytes per second, and the burst maxes out at 250 megabytes per second. Like ST1, again, this comes with a burst bucket. It's the same as ST1, except we have a different baseline and burst fill rates. Common use cases for ST1 and SC1. Again, ST1 is ideal for large block, high throughput sequential workloads, and SC1 is ideal for less frequently accessed sequential throughput workloads such as logging and backup. A customer, Localytics, has written about using these volume types for the data warehouse Vertica. Similarly, Confluent, the company behind the creators of Apache Kafka, have discussed online how to leverage them for stream processing. Splunk, another company, has blogged about how customers use these volume types to save money for their log processing solution. We actually have even heard about customers using ST1 for the commit log for Cassandra workloads. For details, please see the link below. So again, you should consider ST1 and SC1 for applications requiring sequential throughput to disk. So again, on these slides, we see our 4 current generation volume types, but also we see their current price. GP2 and ST1 and SC1 have a pricing model where you pay per gigabyte provision. So for general purpose SSD, you pay 10 cents per gigabyte provision per month. And for a volume type like SC1, you pay 2.5 cents per gigabyte provision per month. IO1 has a slightly different provisioning model where you pay for the 5 gigabytes provisioned, and you pay separately for the IOPS provision. So that's the overview of Elastic Block Store. So in the next few slides, we're going to go a little bit deep dive into EBS and talk a little bit about performance dimensions, and then we'll get into our best practices. So the first area that we're deep diving on for EBS are performance dimensions of IOPS and megabytes per second. We answer how EBS counts an I/O from your application in terms of IOPS for SSD volumes and megabytes per second for HDD volumes. This is really important to understand as it'll help you learn to understand what to expect when you pair your application with an EBS volume. So to begin, how is performance measured with EBS? So for our GP2 and I/O1 volumes, performance is measured in IOs per second, or IOPS. The max size of an I/O that we count is 256 kilobytes. And again, GP2 and I/O1 are ideal for random I/Os with low latencies. ST1 and SC1, on the other hand, the performance is measured in megabytes per second. And the max size of an I/O that we count is 1 megabyte. It's optimized for large sequential I/Os with high throughput. So we'll go through a couple examples to really go through this in detail. But one of the things that EBS does for you is actually, we really want to make sure that you're spending the least amount of money on EBS and maximizing the performance you get with EBS. So when possible, when we see sequential I/Os being sent from your application to disk, we merge them. And for GP2 and I/O1, we merge them up to 250 kilobytes in size. That will help minimize your I/O charges on I/O1 and maximize the burst that you can get with general purpose SSD. So now I'll start with an example. So example one, how do we count I/Os for GP2 and I/O1? So let's say, for example, you have an application sending 4 random I/Os to your disk, all spread out to your volume. And let's say each volume is 64 kilobytes in size. Now the max I/O size that we count for GP2 and I/O1 is 256 kilobytes. So since you're sending 4 random 64 kilobytes, we're going to put them in this example, 4 box cars going to your volume. And we're going to count those as 4 I/Os. In this next example, how about if we're sending 4 random I/Os that are larger in size? Hey, say we're sending 4 random I/Os and they're 256 kilobytes in size. Again, the maximum size that we count for a single I/O is 256 kilobytes, and they all fit into an individual car going to your EBS volume. Again, we count those as 4 I/Os. In this example, we're switching things up. Say we have 4 sequential I/Os from your application going to disk, and say they're all 64 kilobytes in size. So again, these are a sequential instead of random. In this case, when possible, EBS will merge them together and count them as a single I/O. So in this case, we can merge all 4 64 kilobyte I/Os that are sequential into one car and send it to disk, and we count it as 1 I/O. Similarly, again, if we're sending 4 sequential I/Os that are 256 kilobytes in size to your EBS volume, we'll basically fit them, each of them, into one car and send it to your EBS volume and count them as 4 I/Os. So now we'll switch from GP2 and I/O1, how we count I/Os, to talk about ST1 and SC1. As opposed to GP2 and I/O1, where we merge sequential I/Os up to 256 kilobytes in size, since we count single I/Os for ST1 and SC1 as 1 megabyte, we merge up to 1 megabyte in size. Again, this works well for the workloads we've designed ST1 and SC1 for. Workloads with large sequential I/Os such as MapReduce, Hadoop, Kafka, log processing, data warehouses. So again, let's explain this through a few examples. So again, let's start with the same example. Say you have an EC2 instance with your application sending small random I/Os to disk. Say we're sending 4 random I/Os, each 64 kilobytes in size, to your ST1 volume. In this case, the maximum size that we can fit into a single car is 1,024 kilobytes. And since they're random, we can't merge them together. They're random across the disk, so they're going to actually count as 4 I/Os, or in this case, actually 4 megabytes per second of burst. So although we're sending 4 times 64 kilobytes, only 256 kilobytes of data, say in 1 second, we're going to actually count that as 4 megabytes per second. So not necessarily really ideal for random small IOs for ST1, SC1. In this example, the next example, we increase the size of each IO. It's getting more efficient. We're sending larger random IOs. Each random IO is 256 kilobytes in size. Again, each IO can fit in a single boxcar going to your volume. And we count those again as 4 IOs or 4 megabytes per second. In this next example, we're sending 4 sequential IOs, each 64 kilobytes in size to disk. Again, in this case, when we can, we'll merge them all together, and we're going to count these as 1 IO or 1 megabyte in a second. Although we're sending 256 kilobytes merged together, we're going to count it as 1 megabyte per second. And again, one thing to note is EBS says it's best to merge sequential IOs, but it's not necessarily going to occur all the time. There are a lot of random variables in how your IOs get to disk. In the next example, we're going to send 4 sequential IOs to disk. In this case, we're going to send 4 sequential IOs that are 256 kilobytes in size. And those work well together. They're all sequential, and we're going to merge them all together. So you're sending 4 IOs at 256 kilobytes in size. We're going to merge them all together into 1 IO or 1 megabyte per second. So I can see with this example, ST1 and SC1 volumes are really optimized for large sequential IOs going to disk. Again, GP2 and IO1 on the slide, ideal for random IOs with low latencies. And ST1 and SC1 are optimized for large sequential IOs with high throughput. So moving on, our next deep dive is going to be on encryption. We briefly mentioned it before, so I thought I'd go a little bit more into encryption with EBS. So how does EBS encryption work? First, with EBS, it's a checkbox. When you enable encryption, your data is encrypted at rest and flight to your volume. Encryption and decryption of your data is done in the memory of the server hosting your EC2 instance. The data keys used to encrypt your data is never saved to plain disk. It's saved to text, to disk in plain text. Your resources, your volumes, are encrypted with something called a customer master key. And there are 2 types of CMKs. There's a default key, now a default key per account per region, and then you have the options of creating custom keys. You can use either of these to encrypt your EBS resources. Let's go a little bit more detail about how EBS encryption works and how these keys work. So the master key, we have a master key, which is your CMK, and it's called to wrap a data key that is a second layer of encryption used to encrypt your EBS volumes. The master key never leaves KMS, or key management service. EBS stores the encrypted data key with volume metadata, and any snapshots created with your volume are also encrypted with the same data key. On this next slide, we see when you need to decrypt your volume, we call into KMS, have your key decrypted and stored with your EC2 instance. Again, data keys can never be exported from KMS and always stay encrypted. Moving on to the second half of our presentation, EBS best practices. The first best practices we'll talk about are availability related. So our first best practice is, when you can, use multiple availability zones. When architecting with EC2, using multiple availability zones will increase availability of your application. EBS is designed to be availability zone independent. So for example, power outage in one availability zone should not affect the service in another availability zone. Thus, for higher availability applications, to mitigate against a zonal issue, we recommend you architect to use multiple availability zones. Our next best practice is to use EC2 auto recovery. EC2 auto recovery is great for instances using EBS. As you can move the volume from one instance to another. So over the years, EC2 has built up an extremely robust system of status checks covering both your instance and the physical system hosting it. So that's if an instance fails for any reason, you can use EC2 auto recovery to either reboot your instance, or if the underlying instance completely fails, you can use EC2 auto recovery to completely recover to new hardware. EC2 auto recovery allows you to retain your instance ID, instance metadata, your IP addresses, and your EBS volume attachments. EC2 auto recovery is limited to our current generation instances that use EBS storage. In this next section, we talk about best practices for durability. And the first thing that we really recommend for your customers are to take snapshots of your volumes. Snapshots are incremental backups, meaning only the blocks on volume that have changed since the last snapshot have been taken are saved to S3. All snapshots will contain all information needed to restore your volume to the instance that a snapshot was taken. You don't need to worry about deleting a snapshot and not being able to create a volume from another. Now again, a snapshot only captures what data has been written to disk, so you need to do some house cleaning to make sure you get every OS kernel and every application flushed out to disk. So here's the best practice for doing that in Linux. So the first thing you want to do is to quiesce your I/O. So first start by pausing your application, and if you're running a database, doing a flush or lock table, and then on your file system, run a sync or FS freeze, and then issue the API call to snapshot all your volumes attached to your instance. When the snapshot API returns, it's safe to resume using your volume. So it only should be a few moments or a second or two for you need to pause your application when taking a snapshot. Note, we have a variety of volume sizes from 1 gigabyte up to 16 terabytes. And so we've designed EBS such that when you're taking a snapshot of an entire 16 terabyte volume, we've designed it such that it takes no longer than to snapshot an entire 1 terabyte volume. After taking your snapshots, our next best practice is actually manage them. So we talked about the benefits of snapshots, but how do you manage all of them? Without a proper management framework in place, it can be a huge headache. It can be a huge headache to maintain, thousands and thousands of EBS snapshots based on your snapshot retention policy. So in order to manage them, consider using other AWS services. Consider tagging your EBS resources with backup and retention policies, and consider using EC2 run to pause your application in order to take a snapshot. And then consider using the Lambda service to take snapshots and automatically expire them. You can use Lambda to monitor the tags on your volumes along with timelines on when to take them and when to expire them. Just a little note, EC2 Run Agent is a tool that you use to automate administrative tasks such as running a shell script across a number of EC2 instances all at once. And it's integrated with IAM and CloudTrail. Our next best practice is rating. So we recommend you avoid rating for redundancy. As discussed at the beginning of the talk, EBS data is already replicated. And if you use a RAID 1, it just halves the amount of available bandwidth to your EBS volume. And if you're using a RAID 5 or 6, you lose 20 to 30% of your usable I/O to parity. The next section will go over a few best performance practices for performance. Now, although I said don't RAID for reliability, for redundancy, we do recommend you use RAID 0 for performance. So when should you use RAID 0? Well, we recommend you use RAID 0 when your storage requirement to a single instance is greater than 16 terabytes, you have a throughput requirement of greater than 500 megabytes per second, or you have an IOPS requirement greater than 20,000 IOPS at 16K. We do recommend use a stripe size of 128 or 256 kilobytes to maintain a sufficient queue when driving high IOPS. Again, our next slide is best practices. Use the right size EBS optimized instance. So this is really important. We see a lot of mistakes with customers incorrectly attaching the wrong EC2 instance to their volume and not achieving the performance they desire. So let's start with an example. Say you have an application where you need to send 6,000 16 kilobyte operations to your volume using, say, running a SQL database, IO-intensive SQL database. Say you attach it to a C3 extra large instance that's EBS optimized. So if you check the link that I mentioned earlier, you'll see a C3 extra large comes with an EBS optimized performance pipe of about 4,000 16K IOPS, or about 62.5 megabytes per second of performance to your attached EBS volumes. Since you need to attach a volume and send 6,000 IOPS to it, attaching this to your C3 extra large will not work. So if you want to send 6,000 16K IOPS to your disk, you can use a C3 2 extra large that's EBS optimized. This instance comes with about 125 megabytes per second of EBS optimized performance to EBS volumes. And you can achieve about 8,000 16K IOPS, which is sufficient to meet this workload. See the below link for details on the per instance EBS optimized performance. Our next best practice is, use tools to understand your workload I/O patterns. So if you're using Linux, you can use IOstat to gather data on your I/O workloads. And for Windows, you can use perfmon. Our next best practice is to use, for Linux, a modern Linux kernel. So if you're monitoring your I/O to disk and you see your I/O stuck around 44 kilobytes per second, it may be that you're not actually sending small I/Os to disk. It may be that you're using a Linux kernel that does not support something called persistent grants. Persistent grants is an extension to the Xen blockroom protocol, and it significantly improves disk throughput and scalabilities. So we always recommend that you use a Linux version, a Linux kernel greater than version 3.8. Of note, Amazon Linux 2015-03 was the first Amazon Linux kernel to use a Linux kernel greater than 3.8. Our next best practice is for our ST1 and SC1 volumes, and we recommend you increase the read-ahead buffer on your Linux instances. So again, ST1 and SC1 are optimized for throughput-heavy workloads. So when you configure, so we recommend configuring the read-ahead setting to 1 megabyte to optimize the performance. This is a runtime setting per volume configuration. But note, this may degrade performance if you're accessing the disk with small random I/O. I've shown the command below on actually how to set the read-ahead setting for your EBS volumes attached to your instance. There's a link below that goes into more details on exactly how to set this. So again, for ST1 and SC1, consider increasing the read-ahead buffer for optimized performance. In the next section, we talk about some best practices on EBS security. So we do recommend you create your own AWS KMS master key for EBS rather than using the default key. So with creating your custom KMS key, you can much more easily control who can use the key, who can administer the key, and note anything that you encrypt with a default key that comes in your account, you can't share with other accounts. You only can share encrypted data that's been created with a custom KMS master key. That's really to protect you from accidentally sharing your default key with another account. We also really recommend that you enable AWS CloudTrail for auditing. So if you really want to have proper auditing and checking who are using the different encryption keys, that's all logged in AWS CloudTrail. You can see which volumes and resources have been granted access to keys. Oh, jumping up a little bit. This is one performance tip I forgot to mention earlier. Initialize your volume performance sensitive apps. So jumping a little bit back to performance before we get back to security. So if you have a new EBS volume, if you're creating a new EBS volume, just attach it and go. It's ready to go. You're at the performance. It's going to perform as expected. However, the performance difference when creating a volume from a snapshot. When you're creating a volume from a snapshot, the data must be taken from S3 and loaded into the volume. So EBS implements lazy loading from Amazon S3 so that you can begin using the volume right away. That means if you aren't accessing the volume right away, EBS is loading your data in the background from S3. However, if you really want to perform without getting hit with those S3 latencies, we recommend you do a proactive read across the entire volume to accelerate the lazy loading of data from S3. And so that when you're running your application, you're not hit with this S3-like latency. So if you're running a performance-sensitive application, we recommend you reading across the entire volume and loading and forcing the load of data from S3 to avoid potential latency issues. So you can see the link below on an actual command that we can use to initialize your volume. So sorry, jumping back then to some security-related best practices. So when sharing your encrypted resources with another account, we recommend that you re-encrypt them when copying them to another account. So when copying an encrypted snapshot to another account, you must not only share the snapshot with the other account, but you also must share the key with the other account. If the key used to encrypt this snapshot is ever unshared, you will not be able to decrypt the resource in the other account. So consider re-encrypting the resource when copying the data to another account. And as mentioned before, you cannot share encrypted resources created with the default key with another account. So with this, I'd like to conclude with a few simple reminders about this talk. So the key thing to remember from this talk is, first, select the right volume for your workload. Think about, do you have an application that has a lot of random IOs to disk, or is it sequential? And when in doubt, use GP2. Then select the right instance for your workload. Use EBS optimized instances and pay careful attention that the amount of performance that the EBS optimized comes with to disk is sufficient for your workload. We recommend, as part of your backup strategy, to take snapshots and manage them. And then if you have a requirement for encryption, we recommend using encryption. Just click a checkbox and it's ready to go. So thank you very much for the presentation, for listening today and asking a lot of questions. So if you haven't already done so, there are some poll questions, so please answer them. It'll help us out in making the presentation better for next time. So in this next talk, I'll go and answer some live Q&A.
Thanks a lot for a great presentation, and thanks to our moderators for engaging with our audience throughout the presentation. On your screen, you'll see 3 live poll questions. Please provide us with your feedback by clicking the radio button next to your reply for each poll. It looks like we have about 10-11 minutes left, so please feel free to continue submitting questions. We will start addressing some of those questions that have been submitted, but apologize in advance that we might not be able to get to all of them. There's been some really good discussion, so we want to make sure we cover that. I'd like to extend a special thank you to our presenter, Neil, for his time and great presentation, and our moderators, again, for answering all the audience questions. Okay, so now let's go into some questions here. We have a good one here from Akbar. I need a large data set, about 4 gigabytes, that has process needs to access using file APIs. What would you say about running a file server sharing EBS versus EFS? So this could be for any of our moderators, but...
Hey, Neil, it's Drew. I've got some ideas on this. Akbar, a couple things. EFS is excellent as a managed file system because it's available by the drop. It's simple to make file systems and then share them across your instances without having to build and maintain a file server in the cloud that runs on top of EBS. The complexity is far simpler. The condition there, though, is all about the file protocol. So if you need to use CIFS, and we talked about this in a couple of other questions, if you're doing Windows-centric file sharing, EFS, the Elastic File System from Amazon today, does not support CIFS. So if you're using Linux AMIs, this is an excellent way to start building and attaching file systems with a couple of clicks that can scale to petabytes and deliver consistent latencies and throughput. If you're not using Linux and you want to share files, if you're using Windows on your AMIs and your instances, then the best alternative is still to create an EBS volume, format it with CIFS, and share that volume through your instance, much like you're building, in fact, you are building a file server in the cloud on it, using an AMI as an instance as the file server. hope that makes sense. Neil, there's probably some conditions or considerations around designing which type of EBS volume for that application that you probably can highlight better than I can.
Definitely. So we do recommend always starting with GP2 on that side to make sure you're getting the right performance for your application. You always can monitor through CloudWatch or some of the tools we talked about in the presentation to see if you're using EBS to see the actual performance you're getting to disk. With some file share applications, you will have a lot of random I/O to disk and that are small. So sticking with the GP2 is our right volume type to start with.
Okay, cool. And plus the advantage with one other consideration is we don't yet have snapshotting available through EFS. So if preserving those file systems at point in times is a criteria, then using an EBS volume is a better choice.
Definitely. Similar with, as you mentioned, encryption. So encryption is something native with EBS.
Yep, good point.
Great, thanks. That's a great response. Thanks, Drew. Thanks, Neil. So another question came through regarding IOPS and why we don't use IOPS as the measurement for hard drive volumes. This is from Saurav Paul. So thanks for that question.
So why we don't
use IOPS as the measurement for the hard drives?
So for our spinning disk HDD technology, we use megabytes per second as we're optimized for throughput versus IOs per second. So we found an easier way to convey that performance to customers, and it really shows how to maximize the performance to your disk.
We measure both.
We measure both.
Yeah, we do measure both, but as far as for tracking purposes.
I think part of what really helped me understand this is kind of the quick and dirty differentiation. If you're looking for throughput, you want to go with classic disk behavior. If you're looking for IOPS, you want to go with SSD behavior, and that's the rough dividing line between the four types that we have, right?
True. Yes.
Okay.
Great. Thank you. Okay, so another quick question here. Is it possible to convert an existing online GP2 volume to IO1 if it is determined the GP2 does not meet the performance needs of the application? This is from Matthew Young. Thanks for that question, Matt.
Yes, you can do that. The way you have to use that today is using snapshots. So you would have to take your GP2 volume, take a snapshot of it, and then from that snapshot, reprovision it as an IO1 volume and reattach it to your instance.
Great. Thanks, Neil. All right, another question from the audience. Looking to save money on storage through deduplication with net backup in AWS. The backup images are being stored as deduplicated images using Net Backup Media Server Deduplication Pool, or MSDP. This is using EBS storage. Which volume type would be best for this? This is from Greg Chelinsky. Thanks for the question.
Just going to load that up on my screen. So the question was save money on storage through duplication on net backup.
So I think that this is tricky. There are great answers to this, but there's more than one. So I'd say the first thing to consider, Greg, is in your net backup installation, are you taking advantage of the built-in S3 connector? And I'm answering from a broader storage perspective here than just EBS, from an Amazon perspective. Because it's very easy to take your backup jobs, run them through the deduplication engine in net backup, assuming it's on-prem, and then push that into S3. Now, that avoids EBS entirely, and maybe doesn't solving the problem that you have. If you want to use EBS as the target, you can certainly do that. I may recommend that you consider a lower cost magnetic volume, because this is probably, your backups are probably not your highest performance required application or use case. So saving some money and putting them on a magnetic volume works. It's just a question of how you're set up and what your objectives are. If you want more details, we can gladly go into them. Just write us back and let us know here.
Yeah, so definitely, as we mentioned, some of the ST1 and SC1 volumes are very good for throughput workloads, so and for backup at a very low cost. So potentially for your application, use that.
Great, thank you. All right, well, I did see that we had some comments going back and forth regarding Kafka, so I thought maybe we would let Mark jump in and kind of go through and talk a little bit about some best practices to keep in mind.
Sure, thanks. So the important thing to keep in mind, and I'll step back a little bit from Kafka. is that some applications are actually designed with streaming media in mind, and I consider hard disk drives streaming media versus IOPS. Kafka is one of those that was designed for large data, thinking about how do we save costs and how do we best utilize hard drives. So that's why we recommend ST1 and SC1 for workloads like that. Your database transactional workloads are the type of workloads that are going to be better fit for SSD type volumes.
Great. Thank you, Mark. I had another question, a lot of questions on snapshots, so I'll just kind of queue up one that came through. It was pretty specific. It said, let's say I have taken 5 snapshots of the same EBS volume. What happens if I delete the first snapshot?
Sure, I can go to that. So if you've taken 5 snapshots of the same EBS volume and you delete the first one, you still have 4 snapshots and you can create volumes from them. So when you take a snapshot of a volume, we look at what data has changed since your last snapshot and push those to S3. So if you delete your first snapshot, we see that your subsequent 4 snapshots may rely on that data, so we'll maintain the data that's required for the other 4 snapshots. So again, if you take 5 snapshots and delete the first one, you don't have to worry about your other 4 snapshots. You can create full volumes from any 4 of those snapshots.
Thank you. Okay, so let's see. See if I can find some more questions here. We have so many that are in here. So thanks again for all of the questions.
Sridhar asked a question about, really a telling question to me, a simple question, and one that we deal with a lot. He asks, is EBS synonymous to NAS that we use on-prem to share files? And I would say definitively no. EBS, Elastic Block Storage, is like a disk drive that you install into a machine. It understands block interfaces. It needs a host in front of it to translate into file protocols and file interfaces. EFS, the Elastic File System, is much more like, is basically the equivalent to a NAS, except that it's operating in the cloud, and it allows you to share file systems between EC2 instances. So don't make the mistake that it's complicated to build a file server on EBS. It's perfectly functional, and you'll get some excellent performance characteristics, but it's not a managed service like EFS where you can just expand and shrink on the fly, designed to share files.
Great. Thanks, Drew. There's some other good questions in here that are popping up, so thank you for that. Let's see. Another good one here. What is the max number of days you can set expiration tools in regards to the snapshots?
So for expiration, we recommended using additional other AWS tools like Lambda. So in those cases, you would have to set up those policies on your own. So we don't support native expiration of snapshots within EBS. So if you're using tagging and Lambda for your snapshots to create and expire them, you can set the date to wherever you desire. So again, automatic expiration is not currently supported within EBS. You would have to use other AWS services to implement that.
Thank you. All right, well, we're just about at the limit now. We have still a ton of questions. Again, we're not going to be able to get to them all, but appreciate all of the comments and feedback. And again, if you have any comments on on this webinar or previous or upcoming webinars, please get back to us, and we'll make sure to get back to you. And you can email us at aws-webcasts@amazon.com. Your feedback will help us to improve our webinar programming. So again, thanks to Neil for the fantastic presentation, our moderators for keeping us on track and answering all the questions, and for our audience for taking the time to join us today. Enjoy the rest of your day.